How's everybody doing tonight?
Great.
Looks like we scared off some people from last week. Just the diligent people are left, right? I'm going to have 2, 3, 4, 5, 6. Well, it's about half the class. Things are looking up. We'll be able to move even faster now, right? All right. Everybody can do their homework? I'll collect it in a little bit. Let's review a little bit. If I write up here, what is that? If that's a binary number. And what does it mean? Does it mean it's a big, huge number? Well, maybe, but maybe it means something else, right? That was what we were talking about last week. Could it be binary coded decimal? I talked about binary coded decimal last week, did I not? One of you has ratted you out and nodded their head yes, so that's a yes, I did, even though it was in my notes. All right, so how many bits do I have up there? It's hard to count, isn't it? Right? All right, if I did, how many bits do I have up there? 1, 2, 3, 4, 5, 6.
I'll assume it's 60 since F is 15 bits.
No. Okay, if this is binary, what's this?
Hexadecimal.
All right, each hexadecimal symbol represents how many bits? 4. If we have 1, 2, 3, 4, 5, 6 hexadecimal bits, how many binary bits did we have? You see why we do hex? Yeah. All right, now, if I said this was a color, an HTTP color, and this was red, this was green, and this was blue, the intensity of each one, what color would this be?
Red.
No. It's 100% red, 100% green, and 0% blue. I tell you, most of these classes stops at 3rd grade. If you got through 3rd grade, you're good. If you mix red and green together, what color do you get?
Red, green.
No, you mix... Right? Don't you remember mixing the colors together?
Not red and green.
You mix all the colors together. There's your little light experiments. Okay, so we could look at this as a big, huge number, but it could also be a color, right? And not a big, huge number. And if it was binary coded, could it be binary coded decimal? No. The reason it couldn't be binary coded decimal is that if we have 4 bits in each binary coded decimal, that's too big, because the biggest number in binary coded decimal is almost 9, right? Because we go 0 through 9. So this could not be binary coded decimal. And a quick review, if I did something like in binary coded decimal, how many thingies would that be? 8, 4, 2, 1, which is 9, right? 8, 0, 4, 0, 2, 0, 1 is 8. 0, 8, 1, 4, 1, 2, 1, 1 is 7. So that's 987 thingies, right? Is this binary value equal to 987 thingies?
Yeah.
No.
Oh, it's 9 plus 8.
It would be 1, 2, 4, 08s, 016, 032s, 064s, 128, 256, 01024s, 0 something to, right? So it's not equal to 987. So the binary value is not the same as the binary coded decimal value. So when you see a binary value, you can't say, oh, I know what that means. You need something else to tell you how to read that. And that was the same thing we were doing if we were in a computer language. We had to declare a variable and tell it what type of data we're storing. That's why we need to do that, because it needs to know how to read that binary value that's stored in there. All right, so we did binary, decimal, hex. If I did 52, 4D 56, 4D 56, and I said that was hex, could you convert it to binary? All right. Would we have 3 sets of 8 binaries? Because each hex is 4, so this would be 8 bits, 8 bits, and 8 bits. If I told you that this was stored in ASCII, could you look up the binary value for those 8 bits or the hex value for that and convert it into the character values? All right, now let's see how good you are. If I give you the first 2 letters, can you come up with the third one? All right, all right. Now, notice they're all caps. It is not, right? Because small letters and capital letters in ASCII have different values. So they would be different. All right. When we were doing bases, if I had x, 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 point x, x, and I said this was base 12, this is 12 to the what? In a regular base. 12 to the 0, right? This is 12 to the 1, this is 12 to the 2, right? 12 to the 0 is what? 1. 12 to the first is? 12 to the second is? 144. What's this? 12 to the negative 1. If this was base 2, this would be 2 to the 0, which would be 1, right? That would be 2 to the first, which would be 2. And that would be 2 to the second, which would be? That would be 2 to the minus 1, which is equal to what? One half, right? And that's 2 to the minus 2, which would be 1/4. What do you think the next one is? 2 to the minus 3, which would be 1/8, right? Okay. That's using a regular numbering system. Do we have a mixed base systems? Can anybody name one mixed base system? One we use every day. One we're going to use constantly for the next 4 hours. Time, right? Because it's base 60, base 24, base 365 and a half, right? Who was here last week? Does this ring a bell to everybody?
Yeah.
Okay, good. I know it's late. It's going to get later. Okay. If we had a computer system and it had 8 bits in its memory spots, what would be the byte size of that computer system? Correct, 8 bits. Very good. If I had a computer system that had 16 bits in each one of its memory locations, or RAM, what would be the byte size? 16 bits, right? Now, if we had an 8-bit computer, could we have a 16-bit address bus so we could address more than 256 places of RAM? Absolutely, yes. Of course we could. All right. And we used many of those systems. Well, some of us used some of those systems. You all were too old for those systems. But you might remember some game systems, right? Remember, they had 64K of RAM, right? But they only had 8-bit memory locations. But they used 16-bit addresses. If we had 32-bit memories, how much memory could we address using all 32 bits? Nobody remembers this. No one was taking notes clearly. 4 gig, right? Absolutely. This rings a bell, sort of, right? Sort of. Okay. If I had 64 bits, which is basically your modern computer today, how much memory could we address with 16 bits? I mean 64 bits. Sort of gave it away there. 16 what? Exabits, right? 16 exabits. Do modern computers with 64-bit memory spaces, are they set up to address 16 exabits of RAM? No. How much? Come on. Anybody? 64 meg, correct. Right? So even though it can do 16 exabits, it's only set up to do 64 meg because no one needs more than 64 meg. Or so they say. All right. What are we going to have next week? A test. Did everybody take notes on what I just went over? I see a lot of writing going on. All right. Was that a hand up? No. Okay. All right. You'll see that again. Maybe next week. In buying